Um, hello everyone. Thanks for coming. I'm Adi Gangidi. I work for Rackspace. I'm a senior systems design engineer at Rackspace, and I work on a platform that we've developed. It's called Barreleye G2, but we're not here to talk about the whole server. We're specifically going to talk about the storage aspects of that server and specifically the Trimode capabilities that we've developed. So I'm going to briefly just go through the agenda. I'm just going to reiterate what Trimode is and why we think, at least our version of why we think Trimode is important. And we'll go through a little bit of implementation specifics. And we have some samples of the boards that we show in the Open Power booth. If you want to take a look, and it'll be I'll be available there after this talk to kind of talk through some of the specific versions of those boards. So just going to start a very brief introduction of the platform itself, of the server itself. So specifically, I want to talk about the motherboard. The motherboard that we have in our server, it's a SAS motherboard. It's a 2-socket Power 9 design. It's 48 volts. It's got front I/O access. It's got lots of I/O, essentially PCIe and Gen4 and OpenCAPI. It's also got open source, BMC and host firmware. And specifically coming to the chassis, it's a full depth open rack V2 form factor, and we have hot swap fans, VGA access, and things like that. It's a 2OU chassis, so we can fit half-height, half-length cards, and with some adjustments, full-height, full-length cards as well. And specifically coming to the topic of the day, we're talking about high-density hot swap storage bay. High density because it's got 24 drives. It can fit 24 drives, and it's hot swap. We have provisions to support hardware provisions to support hot swap in the server. Specifically, each slot can support SAS, SATA, and NVMe, and we'll go through that a little bit more. That's a little bit of picture of the storage canister that we have in the server. You can pull it out and hot swap those drives. So I want to just review how storage, say local server storage, and in specifically and in general just backplanes as in kind of work. So we have 3 kind of parts of a storage system, right? You have essentially you have the backplane, you have the expander or midplane board, and then you have the controller, the HBA essentially. And that can, the controller can have RAID functionality or not, depending upon whether you want to do redundancy in software or hardware. So the way we act today is basically we have separate backplanes, and depending upon the connector, of course. Like there is some synergy between SAS and SATA with U.2 now, or there's a lot of synergy there in the backplane side. But there are some legacy backplanes that still kind of are specific to specific drives. And when we kind of when we implement our storage solutions, we have dedicated backplanes we develop for all these solutions, right? And then we have different expanders. So if you want to support more NVMe drives, you have a PLX switch. If you want to support more SATA or SAS drives, you have the SAS expander. Again, these 2 are separate as well. And then you have 2 different controllers depending upon which protocol you're trying to expand or support. So it's a lot of independent hardware being present in different implementations, different servers, right? So that's the kind of reality today. And what Trimode storage, as I understand it, the high-level concept of it is that you have essentially one backplane. You have one backplane that kind of merges all 3 or supports all that can support all 3 things in individual connectors. So each slot can support, say, more form factors of the drives or more protocols of the drives essentially. Obviously, just changing the connector, it's not the solution. We also need to essentially, have some degree of, say, unity and cohesion in the mid-plane or the expander board, right? And then also have a single controller, essentially, if possible. That would be the ideal case, right? So it will be the easiest to implement. So so that you have a nice and elegant kind of solution in the server that's compact, and you don't have to say, for different implementations, you don't have to say send an operator to kind of plug and play different hardware, right? So one backplane, one midplane, and one controller. That would be the ideal case, right? And you should be able to, ideally, you should also be able to individually. You don't, if possible, you don't need to power off the server that would, to replace the SAS SATA drive for NVMe or vice versa. That would be the best case, right? So this is the most elegant, say, requirement that you want from Trimode, right? So and then coming to, like, say, a little bit, I want to touch in terms of why Trimode. There is a today we live in a mixed market. I don't think there's a lot of debate about that. There is a little bit debate about where the future is going in terms of what these sliders, where they exactly are. Wide variety of data does point to a mixed market continuing for next, say, 3 years at least, before there's one NVMe getting a lion's share or things like that. It's happening. The NVMe market share is growing rapidly. There's multiple reports that say that we still live in a mixed market, and all these three protocols are gonna be real and in market essentially, right? So if you kind of look at, say, I'm just want to take an example of different deployments, right? Say, let's take bare metal as a service, right? It'll be bare metal as a service is growing nowadays in the market in around just less than 10% or so. And gone are the days where you would talk to a customer and he'd give you a few months or a week or something like that to kind of get that bare metal configuration for him. You want rapid provisioning even in bare metal, right? So in order to do that, say with these separate, say, configurations or storage as it exists today, local storage in servers, it's tricky because, say, you need to build that exact configuration that customer needs, essentially like SKU proliferation, right? You want to consolidate your SKUs, have something that supports everything, and then if the customer needs a specific set of drives, you can do that, right? You can go replace it pretty quickly if the support on the server exists for all these three. So from a Rackspace perspective, we run a complex infrastructure. We have lots of products. We have lots of different deployment models. Private cloud, public cloud, bare metal, and applications like MongoDB and things like that. So we have a full stack of applications, and we have a complex infrastructure. We already have many SKUs essentially, trying to and we're trying to consolidate them as we go. So from that thought, right, when you're building a new server, an open compute server, we thought that it would be best to actually have, essentially one SKU or one server config to kind of rule them all, essentially, right? And that would make it really easy to deploy it. So specifically in the Barreleye G2 storage, there are 3 parts. The host bus adapter. The host bus adapter connects to the storage expander board, essentially, and then the storage expander board in turn connects to the storage backplane. And essentially, the storage backplane does support SAS, SATA, and NVMe in each slot. The point I want to make is, say, so we have 24 drives. 20 of them are SAS, SATA, NVMe, and 4 of them are SAS, SATA only. And we can build hardware RAID. I'm going to show you that in a little bit. And we can do like hot swap, Trimode hot swap as well. One interesting thing is if you kind of take the motherboard away, this solution is pretty independent of architecture or implementation. So anybody in an open who's building an open compute or otherwise can actually take this and use it as is, or take the inspiration of the design and re-implement it specifically according to their requirements. And we've been pretty open about all the stuff, all these things, the schematics, the board files, everything's, up on the Open Compute server work group, and you can basically pick that up and go. I want to highlight the independence of it, independence of the solution, just not irrespective of the server itself. So I have a little bit of demo. I'm hot swapping SATA with NVMe. Maybe SATA, the NVMe devices, the SATA replacement NVMe devices became so cheap, and you want to just hot swap them, right? So let's see if that plays. I think it didn't play. That's unfortunate. I had a little bit of video demo there where I was, the server was up and running, and then replace the SATA drives with NVMe. And then it would basically, the server is still up and running, and you have a store CLI output, before and after. I'm going to post these slides, and make sure the video works. That's unfortunate. I have another kind of display here where basically I have, in the backplane, this is a picture of the backplane. I have 2 NVMe drives, 2 SATA drives, and 1 SAS drive. And I'm issuing a store CLI command to build hardware RAID. And these are arbitrary locations. These could be anything. It's not like these 2 have to be NVMe or anything like that. You could have swapped them and built hardware RAID, and it would work, essentially. So we're able to do that. So we're able to hot swap, and the first demo didn't work. But we're able to hot swap SAS SATA for NVMe, and we're able to build hardware on SATA and NVMe. That's the current state, and things are working in the implementation. So now, kind of, going back, right, specifically, like, say, into the implementation. So the ideal Trimode implementation would have been like this, right? And this is what, when we started designing the server, this is what we wanted to do. So we wanted to have like a Trimode RAID controller so that you can build RAID on SAS, SATA, and NVMe, and then kind of connect it to a Trimode expander, an expander, a storage expander board that has a Trimode expander. And then basically the Trimode expander doesn't independently, send signaling for individual protocols. It would just send a PHY, right? It would just send a physical, you have basically copper connecting the storage expander board to the drive backplane. And these would, transmit corresponding, signaling corresponding to what drives you plug it in. So it would auto-negotiate essentially the time, and this would work, right? And for that, you needed, because how U.2 pins are, and to make, build an efficient backplane solution, you needed a U.3 connector and the support for it. So you also needed different U.3 drives, right? So if all these existed, this would have been an ideal solution. It would have been as if you were building, basically the intensity of the solution and the cost of the solution would have been equal almost as if you were building an NVMe backplane. And no extra cost, but added flexibility of SAS SATA support, right? But things didn't happen, and this would have been 96 high-speed lanes, and that would have been the same as, say, if you implemented 24 SAS SATA. 24 NVMe drive backplane, right? But this is not what happened. So, in the concept of one backplane, right? One connector essentially to kind of support both, right? So today the U.2 basically is on these 4 slots, and the SAS SATA is on these 2 slots, right? They're independent, right? So in order to have like a Trimode or basically a support for all 3 protocols, what you have to do is basically wire all these wires, right? Wire everything and to support it. And to get around that, the standards body essentially is working on a true Trimode connector. That's what they call it, a true Trimode connector. So what they were trying to do is basically move couple of them, either SAS SATA or NVMe, to the others so that you have multi-purpose pins, right? You have multi-purpose pins that are slots that that can do either ways, and that Trimode expander that I showed in the other picture would have negotiated the independent solution. And so this was a good concept. This was actually being in discussion in 2016 when we started basically designing the server. We talked to multiple drive manufacturers, but not many people actually came forward to implement drives in this form factor in U.3. So the first requirement actually didn't happen in 2016, right? So and then the second one is basically a Trimode expander, existence of a Trimode expander, so that you don't have to have a SAS expander and a PCIe switch on the same slot, right? On the same expander board, right? This is expensive solution, relatively expensive solution than this, if you would build an ASIC for this, right? And then you would have had less lanes going out of the expander board, and you would have had an easier backplane as well. This didn't happen as well. There were Trimode expanders in chip companies' roadmaps, but they were dropped. People didn't want to move because of whatever reasons, right? Like the market dynamics, and change comes hard to us humans. Essentially, we want to keep doing these things the same way, even if they're a little bit harder or less efficient. We want to just not change that easily. It has to be a group dynamic, right? So and then the last requirement, or the most closest to the host, is Trimode RAID controller, or a Trimode HPA. Essentially, this did happen. Broadcom implemented a 9460/16i Trimode RAID controller, and this is one of the requirements that actually got satisfied out of the 3, right? So they did implement this. Early 2016, we had samples, and we were testing this, and things looked good there. But we still needed the other 2 to go have this elegant, nice Trimode solution, right? So when you don't have 2 out of the 3 important solutions that are important to build a full kind of say storage solution, what do you do, right? So we dropped the idea of building the most elegant Trimode solution, but we still wanted to implement as a proof of concept, and also for our deployments at least, to have one SKU again to rule them all and to have support all 3. So we did the relatively cumbersome implemented of Trimode, which is double plumbing, it's called, and I'm going to walk you through that essentially. So you have a by 8 or a by 16 host slot, and you can have a Trimode expander or a CAPI accelerator, or just a host bus adapter if you're not into RAID, and then you'll route SAS lanes and PCIe lanes to the expander board. And we use mini SAS connector for transmitting the SAS lanes. We use slim SAS for the PCIe. And then we basically had 2 expanders. It's a SAS expander and a PEX chip, essentially. And those are the numbers of the chips that we used. We built that storage expander. And then, so we routed all the lanes, essentially. We routed all the lanes to the backplane. And so you have a multi-personality drive backplane. We did make a trade-off, essentially due to the wattage considerations. We could have wired all of them as NVMe, all the slots, all 24 slots as NVMe, but we took the thermal considerations into mind, and we have 825-watt support for 825-watt by 4 drives, and others are by 2 drives. Essentially, those are SATA replacement NVMe's that come at similar cost. So, and then we also routed by 1 SAS SATA to 24 drives, essentially, all 24 drives. So, and then we have CPLD for, and using I2C, we have CPLD for LED management and other, hot swap management. And for NVMe, we have, SGAPIO for SAS. So, and then these connectors are all slim SAS. So now, using this trade-off and this middle design, we still have multi-personality slots. We still have, support for high-performance NVMe drives, but it's obviously a trade-off. So we have essentially 80 high-speed lanes in the drive backplane. So you can see it's a pretty fat and thick kind of backplane. So this is actually the boards in picture that we built. So this is the Trimode board. And then this is the expander board. It's got a bunch of slim SAS connectors, as you can see, 10 of them. 3 of them basically expand SAS, SATA. 7 of them expand NVMe. Similarly, you can see corresponding slim SAS connectors here as well. And you have the multi-personality slots here. So if you feel like this is bottlenecking, this is a by 3 by 8 Gen 3 by 8 device. So obviously it's a bottleneck. Even if you want to oversubscribe, this is a huge oversubscription, and we understand that. So till the by 4 RAID controllers get mainstream, we've also tested basically using independent HPAs for SATA and by 16 Gen 3 by 16 like a HPA essentially, and have them independently connected and work through them, and that works as well. We've verified that. So we're working with Amphenol and to kind of evaluate maybe this is a Gen 3 backplane, right? But Gen 4 expanders just are getting mainstream. Broadcom announced their Gen 4 backplane. So we're looking at maybe potentially adding in the next revision of board, adding PCIe Gen4 NVMe support for that backplane, even SAS 4.0. We've looked at it; it's possible. Add maybe the Trimode Expander. Meanwhile, basically, while we implemented the standards body moved, and they approved the U.3 spec and the connector in November. They also have another specification for universal backplane management. And both of these are cruising together. So maybe, and there are some reference design on how to implement U.3 backplanes, Gen 4 and SAS 4.0. So maybe, if there is interest among the community and if there's more people interested in consuming this, I think we'd be interested to collaborate and evaluate maybe, doing that. You can also just take your U.2 if you're building a new U.2 NVMe backplane and use our reference and add SATA support essentially to your NVMe backplane if you want that flexibility. We want to thank all our partners, and hopefully you get on board with us. And we have the design package as a part of the larger Barreleye G2 specification. All these board files and specs, everything's up there. We'll work with the storage subgroup to maybe independently contribute this as like a point one, and then maybe work with the community to upgrade that to a true U.3 and not a double plumbed but a single plumbed kind of design. Thank you. Thank you.
Okay, we have time for a couple of questions.
No, it's good.
Cool. All right.
Thank you.